Hello, let the beautiful math continue. For now, we're talking about set language and notation. In notes 1.3, we talk about the terms of the union and intersection of sets. So the union, basically depicted by this symbol that looks like a U, and the intersection of sets, depicted by this symbol that looks like an N. Right, and again we'll be using and referring to Venn diagrams to represent them diagrammatically and to do some shading and even listing. So if you go down to the definition, the union of two sets is the set of all the elements in the two sets. So if you want the simplest way of describing this, it's like I'm adding every single element of each set together. How about the intersection of sets then? It's all the elements that are in common between them. They must be shared in common. Okay? And in that, these two definitions actually talk about a separate group of things. So when I talk about the union of A and B, it's written in this way, A union B. It's talking about adding up all the elements of A and B and creating a new set. So this is a set itself. On the diagram, you can think of it very easily, like how it's represented here, where everything from A originally is now added to everything inside B. So on a diagram, it's really quite intuitive, just everything that you see in A and B. Whereas for the intersection, once again, this is a set, a very unique set of things only in common, commonly found between A and B. And it's talking about only elements found in this small area here, the overlapping region. So let us take a look at a few questions that test our definition of the union and intersection. Here, example 1, we have our universal set, the biggest set, consisting of 1, 2, 3, 4, 5, 6, 7, 8, P and Q. Now, look, they want us to list the elements in P union Q. That is a set itself. So if I look at P union Q, union means adding everything up. So P union Q is the set consisting of 1, in ascending order, 1, 4, 5, 6, 7, 8. Notice I added everything from P and Q together. If there are overlaps, we will ignore it, because in listing a set, we do not show repeated elements. Next, P union Q, and after I've known that, I want to find the complement of it. Remember the complement? What's the meaning of that? This little small symbol that you might have missed. The complement refers to everything outside of that set. So I will first just take a look at what's inside P union Q here, and I take a look at what is in my biggest boundary, the universal set. What is missing from here will end up in P union Q complement. So if I use my highlighter, I see that 2 doesn't appear in P union Q, neither does 3, 4, 5, 6, 7, 8, all appears. So P union Q complement consists of only the elements 2 and 3. And notice that P union Q added to P union Q complement actually gives us the whole universal set. Next, question 2. Universal set, let's use the blue. Okay, it's this biggest boundary of all these elements. Okay. A is here. B is here. Now, find in part A intersect B. Remember, it is in common. They must be in commonly found in set A and set B. So I take a look at set A and set B over here. What's in common? Yeah, I see a 5 that's in common, yeah. Yep, and also a 12. So that's in common. So A intersect B is the set of the two elements 5 and 12. Next, A union B. Recall union means to add everything up. So I start from smallest to biggest in ascending order 2, 5, 8, 9, 10, 12, 16, and 18. Done. Next, I will again highlight my biggest universal set. All positive numbers from whole numbers such that x is less than or equals to 21. So 1, 2, 3, 4, 5, 6, blah, 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 all the way till 21. Next, let's take a look at our smaller group. A, numbers divisible by 3. So common tip, let us quickly take your pencil and list down everything that you know that can be divisible by 3, but still within the universal set. So numbers such as 3, 6, 9, 12, 15, 18, and 21. Okay, very useful. Next, what else can I say? B. B is a multiple of 18. Not many multiples of 18 and still within the universal set, and you only have the number 18. Very simple. So first one, A union B. Recall union. Union is to unite, right? So I'm just really adding all the elements up. So it's made up of 3, 6, 9, 12, 15, 18, and 21. That's A. B, A intersect B in common that you see between A and B. So I see 18 and 18 in common, nothing else. So A intersect B is just a set of the element 18. That. Right, for the final type of question that that's very synonymous with set language is actually to shade the region associated with a written set. So there are some very basic things you need to know. First, that if it's too complicated, you should actually draw it out. But in simpler cases like in part A, where we're talking about the intersection of A and B, this is pretty obvious, right? It's just this region over here, the overlapping region between A and B. For A union B, I think that's pretty simple also. Because of the idea of addition, I basically shade everything inside A first, and I add on everything inside B next to it. So A intersect B and A union B usually are quite straightforward. Now when it comes to more complicated sets like A union B complement, I suggest you just do a quick sketch at the side of the original set, which is inside first. So if we know from part B here, A union B is actually talking about everything inside the two sets. So now once I show the complement here, it's talking about everything that's outside of it. So then I know that it has to be the shading of everything outside the two circles. Here, A complement, union B complement. If it's complicated, let's just draw A complement separately and B complement separately. So A complement refers to everything outside here, and B complement refers to everything outside of B, the right circle, and I want to add them up. That would refer to the first diagram, right? And I'm adding everything from the second diagram, which includes this part. So there you have it. This is A complement union B complement. Now I'm going to go through 4 more examples on the shading of Venn diagrams. Now on your notes, if my student, you should be on the Files app and you can easily actually add a blank page to add in these 4 questions. So let's shade A complement intersect B complement. Now, some of us can visualize this very easily, but if we can't, like I said, just do a sketch at the side of each one. What does A complement look like? What does B complement look like? Very quickly, A complement looks like this. Right, everything outside the set A. B complement looks like this, everything outside the set B. So what is in common between them? Take a good look at both of these shaded areas and you will realize that the common area refers to everything that's outside both sets. Okay, look carefully and hopefully by drawing diagrams at the side, it helps you visualize it. Next, A intersect B complement. Like I said, might be easy for some of us, not so obvious for the rest of us. A is obvious, right? It's just shading A. B complement, everything outside of B. So what is in common between these two sets? Very good. Just this region over here. Part of A, but not that overlapping A intersect B region. Next, A intersect B complement. Do this inside, then outside. So inside is talking about A intersect B. So by right, it should be here, right? That's A intersect B. But if I want to put a complement to this, is everything not shown there originally. So that would mean everything else besides that overlapping region in the middle. So this is A intersect B complement. Last, what if they start to show you multiple sets like this? Looks confusing, but once again, just be grounded by listing out each set individually. So A itself looks like this, right? Just the left circle, that's A. A union B complement is talking about A added to B and I complement it, meaning everything outside it. So what am I going to do with union? I'm just adding everything up. So I will have actually everything inside A and adding everything that's outside here. Right? And we are done. Lastly, I'll just stop at question 5. I'm not going to do question 6 because it starts to confuse people. Right? The set notation of this shaded region. So sometimes they shade it for you and ask you, can you write this down? So you notice that you could split it into 2 parts, right? Here and here. And if I use the union symbol, I can actually write down this set. So the one in the middle actually is A intersect B, right? So let me just show you. A intersect B is this region, right? And I'm going to add, because of union, the outside region. So how do I write the outside region in set language? It's actually A union B complement. You've seen this a few times in the previous example. And we're done.